Let us understand average velocity, average speed with an example. Here example is given. A particle is initially at B, as shown in the figure at B here, and it takes 5 seconds to come from B to A. It comes from B to A in 5 seconds. Find 1. Displacement of the particle during the time interval, and 2. Distance or path length of the particle, and average speed of the particle and average velocity of the particle. Solution. In displacement, we know that displacement is given by final position minus initial position, so x2 minus x1. Here final position is at A, so we have written xa minus xb, initial position. Now final position is minus 10 and minus of initial position 20. This equals minus 30 meter. With sign it represent displacement. Negative sign shows that body has moved in the leftward direction. That is negative. Also this sign represents the direction of movement, because displacement is a vector quantity. Now if we take the mode of displacement, only 30 meter will be the answer. Here magnitude of displacement is 30 meter. From figure you can see what had here. Let's see the figure. Yeah. Because body initially was at B, and it has moved at A, that is in leftward direction, and this is our origin. The situation is shown on a reference line with reference point O. We know that the right side is taken as positive from reference point and left side is taken as negative in Cartesian coordinate. So our body moves from B to A in 10 seconds, 5 seconds. So we have written final position is at minus 10 meter and initial position is as 20 meter. So x2 is minus 10 meter and x1 is 20 meter. So we have put the value to find the displacement, and the displacement has come out to be minus 30 meter. Negative sign shows that the body is moved in the leftward direction, and magnitude of displacement will be 30 meter. Now distance or total path length will be BO plus OA, and 20 plus 10 equals 30 meter. Now average velocity equals to displacement at the time interval, so minus 10 30 meter by 5 minus 6 meter per second. Negative sign shows that body has moving with this velocity in leftward direction. If we write magnitude of average velocity, then will be only 6 meter per second. And for average speed 30 meter by 5 second equal to 6 meter per second. Now next question. In the above example, particle is initially at B, moves from B to A in 5 seconds, and further A to C in 5 seconds, and finally come to rest. Find A displacement, 2 distance, 3 average velocity, and 4 average speed during the whole motion. So in example we can write displacement x2 minus x1, or xc minus xy. Xc as minus xc position C is at minus 20 meter from reference point, and xp as 20 meter. So our displacement will be minus 40 meter, and distance will be total path length, so that will be 40 meter. Average velocity, displacement by time minus 40 by 10 second equals to minus 4 meter per second, and average speed, distance what the time or 2 meter by 10 seconds equal to 4 meter per second. This is the answer. Now let's talk about instantaneous velocity. It is defined as the limit of the average velocity as the time interval delta t becomes infinitesimally small. It is also simply called velocity. Mathematically, v equals to means instantaneous velocity is represented by only v. V equals to limit delta x by delta t tends to 0 equals to dx by dt, because this term is written as dx by dt. Now instantaneous speed. It is defined as the limit of the average speed as the time interval delta t becomes infinitesimally small. It is also simply called as speed. Hence instantaneous speed v equals to limit delta t tends to 0 delta s by delta t, where s is the distance, or this can be written as v equals to ds by dt. Some important point: instantaneous speed at any instant is equal to the magnitude of instantaneous velocity at that instant. Graph for instantaneous velocity. Here a graph is shown between position and time, representing position and time. And there are different here a point P1 and a point is taken at time T1 and at time T2. The position of at P1 is x1 and position at P2 is x2. Now, uh, now the mathematical is slope line P1 P2 represent average velocity between the time interval T2 and T1. So V average is equal to tan theta slope x2 minus x1 by T2 minus T1 equals to delta x by delta t. And now we want to calculate instantaneous velocity at point P. So what we have to do, the slope of the line P1 P2 gives the average velocity between time interval delta t T2 minus T1, that is 5 minus 3 is equal to 2 seconds. As we decrease the time interval, the line becomes close to the tangent, and when delta t tends to 0, the line is tangent and P. From it we can conclude that the slope of the tangent at any point gives the instantaneous velocity. What does it mean? That consider here point P here point P1. So, and if we decrease from both side time interval equally, then becomes like at T1 becomes at T2 becomes from this side at T2, and similarly decreasing we reaches at point P, and that time interval will show the instantaneous, and that time interval in that time interval it will show the instantaneous velocity, that is average velocity will be changed into instantaneous velocity when delta t tends to 0, that is time interval is becomes not becomes very near to 0, then that will represent the instantaneous velocity. At an instant gives the instantaneous velocity. So instantaneous velocity v limit delta t tends to 0 delta x by delta t equals dx by dt equals to slope of the tangent at that point. Mathematically, the position will be given as the function of time. The differentiation of this function with respect to time will give the velocity. For example, here the position as a function of time is given t square plus 2. Find velocity at time t equals to 4 seconds. That is, this will represent instantaneous velocity, because we are calculating velocity at a particular time, not between the time interval. So we have formula for v instantaneous velocity. V equals to dx by dt, where x is the displacement is the function of time, or we put the value of xt from this, and d by dt equals to t square plus 2, taking differentiation, dt2 by t square by dt plus d2 by dt, this will be 0, and its differentiation will be 2t, so we have written 2t plus 0. Now this implies instantaneous velocity has become 2t. Now at t is equal to 2 seconds, put the value of t. So v equals to 2 into 2 equals to 4 meter per second. Answer. If we find the graph with the help of graph, then find the instantaneous velocity and time t 5 seconds. This is simple. We take the a point at 5 seconds and draw a perpendicular line. Here it cuts the graph. We mark this as a point and draw a tangent, and tangent will cut the x-axis at any point on x-axis, and draw again, from any point on this line, draw a perpendicular to the x-axis. This will become a triangle. Now calculate tan theta, and that will give the instantaneous velocity at time 5 seconds. Here it is drawn. This represents point 5, point at 5 seconds, and we have drawn a tangent and it cut at this point, and again here we have taken a tangent at this point. This point cuts the position axis at this point, and so if we take tan theta, that will be instantaneous velocity. V equals tan theta 18 meter by 6.40 second equals to 2.8 meter per second. Answer. Next example, the position of an object moving along x-axis is given by x equals to a plus bt square, where a is a constant whose value is 8.5 meter and b is a constant whose value is 2.5 meter per second square, and t is measured in second. What is its velocity at t equal to 0 second and t is equal to 2.0 second? What is the average velocity between t equal to 2.0 second and t is equal to 4.4 second? So we have x equals to given x a plus bt square. So instantaneous velocity v equals to dx by dt, d by dt a plus bt square, d by dt plus d by dt bt square. This will be 0 plus b into dt by dt or b into 2t. Now at t equal to 0, v will be instantaneous velocity, v into 2 into, put the value of t as 0 meter per second. So at t equals to 0, the velocity is 0 meter per second. Again at t equal to 2 second, put the value of t as 2. So v will be v into 2 into 2 equals to 4b second. Again put the value of b. So 4 into 2.5 meter per second square into second equals to 100 meter per 10.0 meter per second equals to 10 meter per second. Answer. Now average velocity xt2 minus xt1, that is position at t2 and position at t1 divided by t2 minus t1. Here xt2 will be a plus bt square from the formula. So we have put in t as t2 square and put the value of t2 for 4 seconds. So x4 equals to a plus b into 4 square, a plus 16b, or xt1. Now again xt1 will be a plus b t1 square, and t1 equals to 2 seconds. So x2 will be a plus b into 2 square, a plus 4b. Hence v average velocity x4 minus x2 divided by 4 minus 2. A plus 16b minus a plus 4b divided by 2. A plus 16b minus a minus 4b by 2. At 12b by 2 equal to 6b. Now put the value of b. B 6 into 2.5 equal to 15 meter per second answer. Next, uniform motion velocity is same as the average velocity at all time. As in the uniform motion, the displacement time graph is a straight line, so its slope at every point is same. So the average velocity and instantaneous velocity is same.